NCR Corporation is a leader in omnichannel solutions, turning everyday interactions with businesses into exceptional experiences. With its software, hardware, and portfolio of services, NCR enables nearly 700 million transactions daily across financial, retail, hospitality, travel, telecom, and technology industries. NCR solutions run the everyday transactions that make your life easier. NCR is headquartered in Atlanta, Georgia, with about 30,000 employees and does business in 180 countries.
Hi everyone, thanks for having me here. Man, when I was some of your age, I would have been so excited to know that one day I'd be speaking here. So thanks for coming. And I know you're expecting me to be talking about programming and privacy, but what this talk really is an answer to the question, Gene, are you really going to spend your life in a windowless room programming computers all day long? Because believe it or not, when I was growing up, quite a few people asked me this question. And the short answer is no. So I'm a professor of computer science, and you might be wondering, well, what does this actually mean? Part of what I do all day is something called research, which we'll get more into in the rest of this talk. But I read papers, I learn things, and I try to make cool ideas a reality. So I test those out, and I think about a lot of things all day. That's kind of what it looks like. And my specific research is about programming languages for security and privacy, which means that I think about how to help programmers write the programs they intended to write while keeping your secrets safe. And you might have heard that professors also teach. I do that too. Here's a selfie I took with my class from last spring. It was a class on software security, so it was about how to help software keep your secrets safe. And when I was growing up, I really imagined researchers as being alone in their attics or maybe some windowless room or a lab somewhere, thinking of ideas on their own. But what I realized is that it's a really social process. And so I spent a lot of time hanging out with my research group, not just socially, but also working on problems together. So part of this is to train students about how to do research, and part of this is to make progress on research problems together. And a cool part of my job that I never anticipated was that I have collaborators all around the world. So I actually spend a lot of time traveling to different places. I was in both England and France last summer doing research, and also in Spain talking about my research. But it's really social, and it's not just social in Pittsburgh where I live, but really all over the US and all over the world. And that's been really exciting to me. And so I haven't been doing this my whole life, so let's talk a little bit about how I got here before we get into the actual research. I was born in China, where I lived until I was 5, and one of my main hobbies then was cutting very small things out of magazines very precisely. I don't know what that has to do with what I do now, but maybe you'll find some connection. I lived in Pittsburgh, Pennsylvania after that until I was in college, and people always ask me, well, did you always know that you liked programming? When I was a kid, I liked dinosaurs, outer space, the Bermuda Triangle. I read like every book I could find about that, and also arts and crafts. And I also did start programming at a pretty young age, but that definitely wasn't everything that I liked. And I also had the good fortune of growing up literally across the street from Carnegie Mellon University, where I work now. And so I was lucky enough to attend a bunch of extracurricular weekend and summer programs at CMU that gave me exposure to math and science and a lot more computer science than probably I would have gotten exposure to otherwise. And a fun fact is that my current department head's wife taught me statistics when I was 10. And so it was really funny coming back and meeting her again after all those years. But even after all that, I still didn't quite know I wanted to study computer science. So I went to college. I was at Harvard, and I considered studying economics, psychology, and computer science. And both my parents, who are computer scientists, told me, as you might expect, not to study computer science. So I guess you should always worry when your parents do something and then they tell you not to do it. So I took their concerns to heart, but I realized computer science was really what I liked. So that ended up being what I studied. I did an internship at Google the summer before my senior year. So that was when I was trying to decide what am I going to do for the rest of my life, or at least for the next few years. And my father, both my uncles and also my grandfather all had PhDs. So I was wondering, well, should I get a PhD too? And at Google, on my team, everyone either had a PhD or they had dropped out of a PhD program. So I spent a lot of time hanging out with these PhD dropouts, and I asked them, should I get a PhD? And I expected the answer to be no, but they actually said, well, you should, because if you don't try it, how are you going to know if you like it? You can always drop out like us. And I said, that's a pretty good reason to try it. And so I got into MIT. I ended up doing my PhD there in programming languages, which is what I work on now. And I didn't drop out. So here we are now. So on the left is a picture of my research group. It's a real picture of my research group as a fake band. And on the right is a real picture of my research group posing for a shot for German TV. So they're making a TV show or a TV clip about how Pittsburgh is on the rise. They wanted to show some researchers, so they said, could you get together and look like you're doing research? So what I learned was most cool photos that I have, actually someone told me to look like I'm doing something else. But it doesn't mean that what we do isn't real. So we do some real work trying to make software more secure. And so now on to the real topic of this talk, which is, who are all my cat lovers out there? Oh, good. Well, I've come to tell you, you should be careful who you tell about this, because your secret is not always safe. Maybe even if you're okay with the world knowing you're a cat lover, you might not be okay with them knowing other things. And we'll get to that. All right, so who out there has an Instagram account? Okay, whoa, more people with Instagram than cat lovers. I thought everyone loved cats. But, well, you should probably know by now that social media doesn't really keep your secret safe. So that should not be as big of a surprise. And what I learned recently was that even without me asking who loves cats and who loves Instagram, the internet knows. So I don't know if you've seen the site before, but it's called I Know Where Your Cat Lives. But yeah, so apparently, on Instagram, who is careful about their location tags on Instagram? Okay, not as many of you who use Instagram. So on Instagram, you can post your location. So usually this happens when you're at a restaurant and you say, my food looks really good, or you're at a scenic spot and you said, hey, look, I took like a really nice picture of the Sagrada Familia or something like that. But what people might not realize is if you're in your home, and you take a picture of your cat, and cats usually don't leave the home, so if you take a picture of your cat, people probably know this is your home, and you tag the location of that as well, people can figure out where you live. And so there's a whole website, in fact, so many people do this, that there's a whole website dedicated to all the people on the internet who are posting their pictures of their cats and tagging their homes. And so, yeah, liking cats is a little more dangerous than we might think. And it's not just about cats. It turns out people are posting their locations for all kinds of things. And so, in fact, so many people are posting their locations that there's another website called Please Rob Me that's dedicated to raising awareness about not posting your location on the internet. So it takes location posts from places like Twitter and Foursquare and shows just how much information people are revealing online. And if people are at home certain hours and they're repeating these patterns, well, other people can mine that information and figure out exactly when people are not in their homes. So one takeaway for now is be very careful who you're sharing your location tags to, but that's not the whole story. Otherwise, I wouldn't necessarily have a job. And it's not just locations either. So how many of you guys use Facebook Messenger or something where you can see when your friends are online and when they're offline? Yeah, it's getting pretty common these days. So actually, I'm super scared about which of these apps that I install on my phone these days, because what this one person showed was, so with Facebook, there's something called the Facebook API, which allows programmers to write programs and actually just like use programs to ask questions about all the data about all the friends that they can download off of Facebook. And what you can do with the Facebook API is actually figure out when all of your friends are awake and when they're asleep. Yeah, so as soon as someone wakes up, it shows they're online, or even if their phone is active but they're not on Messenger, it shows that they're online. When they go to sleep, they turn off their phone, they become inactive. And so you can actually figure out when your friends are awake and when they're asleep. This was really scary to me. And you might say, well, that's creepy, but is it really so bad? But there's all this research that talks about how people can figure out if someone is depressed or if they have other kinds of things wrong with them based on the frequency of when they're posting online. Or if someone goes offline for a while, you can tell other things about them. So it's actually not great if people are revealing this kind of information without trying to. And it's not just about individual privacy anymore. So if you've been following the news lately, you're probably starting to see that privacy isn't just about individual people getting robbed, or maybe their insurance prices going up, or their employers knowing that something might be wrong with them. But there's this company called Cambridge Analytica that was taking Facebook data at large scale. So on Facebook, there are these quizzes that are pretty popular. So how many of you guys have taken these quizzes? Yeah, so it says, find out what kind of cat you are, or which of your friends you should live with, or something like that. And now click yes, and then we'll look at all of your Facebook posts to analyze them. And so probably you've thought, well, why do they need all of my Facebook posts, but they're just trying to figure out what kind of cat I am, so it's not a big deal. Well, it turns out that if you collect what kind of cat 50 million people are, you can figure out a lot of things about an entire society. And so what these people did was they used AI to take all this data, like Facebook data, posts, likes, that kind of thing, and build models of how people actually work to influence culture. And so everything I've told you about so far is actually just all of the ways your information could be used, even when you're consenting to release that information. But there's also all the information that you didn't mean to release. And that's really what our group is in the business of protecting. And so for us, protecting the data that you didn't consent to give out is the first step towards all of this other kind of protection. And so at this point, you might say, well, it seems better to actually just live off the grid. Maybe we should just all go offline. The information revolution, that was just not a good idea. We should just live in caves again. And you probably would agree with me that that's not the optimal solution. We do get a lot of benefit from sharing our information. And so the question I'd like to ask is, how can we build a future where we're not living off the grid, we're still sharing information, but we can do so with some guarantee that our information isn't going to be used in totally unexpected and potentially bad ways? And so to start, I'd like to make the observation that privacy issues actually aren't new. So this is a picture of me at about your age. I think I was 15. And this was my first exposure to privacy and how it can come back to bite me. So my main interest at that time was going on AOL Instant Messenger, which probably for the younger people in the audience you didn't use. But back then, this was our one way of talking to our friends if we weren't using phones. And my mom thought that going on AOL Instant Messenger was going to be the end of me, so she did not allow me to do that. But for me, all my friends were on AOL Instant Messenger. That was just what people did after they got home from school. So I didn't like this. And so she wouldn't let me use AOL Instant Messenger on our home computer, and so I wasn't allowed to install it. But I found a loophole, which was you could go on the AOL website and use Instant Messenger from there. And I thought I was pretty clever. I made sure to delete my browsing history so no one would know. And then one day my mom confronted me and she said, "I know, you've been on AIM." And I was like, how? I've covered my tracks. And she showed me. So when your mother's a computer scientist, things are pretty tricky. But what she showed me was your browser actually keeps these things called cookies. So when you go to different websites and you log into them, they'll store cookies to make it easier to log in later. And these cookies also give a way for someone else to figure out what sites you've been on and also what information you've been sharing with those sites. And so to me at the time, I was like, well, this is just an extension of things my mom does in real life anyway. This can only happen with people who, because we're sharing a personal computer, our whole family together. So I wasn't so worried then. But I'm a lot more worried now. And one reason is because there's just a lot more incriminating data. And it's not even that I'm doing more incriminating things, but I'm just generating a lot more things that people can look at. So, most of the time I don't go anywhere without my smartphone. My phone has a camera, it has a microphone. I'm sending messages on that all day. I'm browsing websites on that all day. And so there's just a lot more digital data that people have access to. And the people who are accessing it are not just people I'm sharing my phone with directly, but anybody on the internet. So on the left, who's used MIT Scratch before? Cool, so it's really getting out there. But on the left, so things like MIT Scratch, which I show there, are making it really easy for anybody to write programs. In fact, a couple years ago, I wrote an article about how these girls in India are using something like MIT Scratch to write apps to help their community, so to prevent fires and to prevent, to report assault and things like that. But these very young girls are able to write very powerful programs. But what this means is I can go onto the App Store, download an app written by pretty much anybody. Anybody has access to it, and they're asking for all kinds of data. Now they have access to my phone. And then there's also the usual fear of someone in their parents' basement just like hacking into my computer and just looking at my cookies and seeing what I've been doing. Or worse, doing things to my computer, taking all my credit card information. There's a lot worse things that can happen to me now than my mom knowing that I go on AOL Instant Messenger. But the really powerful thing is that people can write programs to access all of your data. And so it's not just people looking through this stuff by hand, but like I showed you with the figuring out when you're asleep or awake, people can figure out this information at a super large scale. And so when it becomes about writing these programs, to me, protecting our data is about understanding the programs. And that's what I'll be talking more about today. But before we get into that, I'd like to make sure we're all on the same page about some terminology. So data, when I say that, that's information. So that's what's coming in our cameras, what's coming in our microphones, the text messages we're sending to our friends, browsing history, things like that. Software uses data to do things. So software is what allows me to make credit card purchases online, send selfies to my friends on Snapchat, which I don't do anymore because I'm very worried about privacy, and all kinds of other things that I might want to do on my phone. And programming languages are things like MIT Scratch, or you might have heard of JavaScript or Java, C, all these other things, and they are how people make software. And so software is always created using a programming language, and then someone turns that programming language into something that you can run on your computer or on your phone. And what we're going to be concerned with today is how we can use programming languages and design better programming languages to understand what data our software is leaking, and also to make sure that it's not leaking the data that we don't want it to leak. And a funny side story is in college, my mom came for a parent visit weekend, and I took her to my programming languages class, and I thought this was just the coolest class ever. And afterwards, she said, "Jean, you don't have to take such boring classes." And so, I think this is the coolest stuff ever. And so I hope to convince you this is super relevant, and also there's a lot of cool stuff going on here. All right, so the problem I see is that even though a lot of the problems with privacy these days are about computers and digital things, a lot of our current mechanisms for protecting privacy are still largely non-technical. So the best way we have today of making sure that our information doesn't leak is to rely on things like governments to punish the bad guys after a leak happens. So we hear a bit about these big breaches and attacks, and we expect what's going to happen is these companies are going to crack down because they don't want fines and they don't want people to stop using their service. But for someone like me, I still remain very scared that there's going to be some new way of, if I like a cat on the internet, someone's going to know everything about me or steal all my information or something like that. And so I would like a better way of protecting my information. And so you might be wondering, well, why can't we have that? And the problem is that it's currently very hard to figure out what software is actually doing. And so what software is it's lots and lots of lines of code. Something like Facebook is reported to be 62 million lines of code. And in the code, secret information and other kinds of information are just all mixed together. There's no difference. All of it is just data. And in order to make sure that this code is not leaking information, someone like me, I brought a prop, has to go through and inspect potentially every single line of code. They go through and they say, is this line of code leaking information? Is this sending my camera information out to the network or something like that? And this is a lot of work. So what happens is when people are writing code, they go through and they inspect their own code, but no one has any clue how all the code works together. And if you're someone working for the government inspecting this code, forget it. Right now, people who didn't write the code have a really hard time looking at code and reasoning about what it's supposed to do. And so it's no wonder that we're seeing lots of problems popping up. So it's not that software developers didn't learn how to write code right or something like that. It's that they have to protect data over and over again across the program. And whenever people have to do the same thing over and over again, they make mistakes. So in the last years, we've seen very large, very legitimate companies having all sorts of breaches. So this isn't even the stuff I was talking about in the beginning where people were willingly sharing their information. This is people thought their information was safe, and it's being leaked. And so people have asked me, well, Jean, can't encryption and blockchain and things like that solve a lot of the problems. And it's true that, so what encryption does is it gives you a way to protect values, but that's only one part of the story. The other part of the story is who are we protecting these values from? And that's a really big part of the problem. That's what we work on. So I'm going to talk about a couple of leaks to illustrate why, even with encryption, we still have a lot of things to work on. And so who here has a secret Twitter account or a secret Instagram account that only some of your friends know about? Well, I guess since it's secret, you guys aren't going to admit it. But I have a much younger sister, and she has all kinds of secret accounts all the time. It's really hard for me to find them. But it turns out that the former FBI director, James Comey, also had a secret Twitter and Instagram account. But he publicly talked about having one. And this is all about how a leak allowed us to figure out what it was. And so at one point, when James Comey was still the FBI director, he said in an interview, I have a secret Twitter account. It's very confusing why he said that. And I have a secret Instagram account with 9 followers. And so there was a journalist, Ashley Feinberg, who said, well, this is definitely a challenge. Why else would he be saying this? I'm going to see how long it takes for me to find this secret account. Took her 4 hours. So how she did this was she thought, well, James Comey is very famous, so I can't find him on Twitter, so I'm going to go after his family members. So what she did was she searched for each of his family members on Twitter, and she found a mention of his son, Brian Comey. So Brian Comey was a university student. His university posted, congratulations, Brian Comey, something, something. And that had a photo that linked to a photo on Instagram. So then she said, maybe I can find Brian Comey on Instagram. So she goes on the Instagram photo. It didn't link to his account, but she looked in the comments, and someone said, congratulations, Brian Comey, linking to his Instagram account. And so then she got there. And Brian Comey, being James Comey's son, also had a secret Instagram account. But then a very strange thing happened when she followed him. So she requested to follow him. And so if you use Instagram, you might know that on Instagram, there's such a thing as protected accounts. If your account is protected, then your photos are protected, but also who you're following and who's following you should also be protected. So she requested him, and he didn't accept her yet, but a very strange thing happened when she looked at the suggestions. So can you guys see what's happening? Yeah, so it'd be very strange if out of all people on Instagram to recommend, Instagram decided to recommend Comey family members, who Patrice Comey is. And so then she said, it's a bunch of Comey family members and then this mysterious Reinhold Niebuhr. I'm going to look more into that. Well, it turns out Reinhold Niebuhr is the name of the theologian that James Comey wrote his senior thesis on in college. And there's also a Twitter account, Reinhold Niebuhr, that's followed by a bunch of government people. And so, yeah, this article circulated for a while, and then that's how we got to the other article where Comey said, yes, I am Reinhold Niebuhr, which was like, it's a pretty, so for those of you who have secret Instagram accounts, it's probably like a pretty either exciting or bad day when you have to admit on national news that this is your secret Instagram account. But really, it wasn't Comey's fault, right? Because this is really an information leak with Instagram. So Instagram did an okay job of protecting this follow information for individual profiles, which is why we have faith that Instagram should protect us. But then if we look in the suggestions, it's totally creepy. And I talked to people about this, and they said, well, suggestions are just creepy. I'm sitting in the library, and Facebook is recommending me people near me to be friends. And that's totally a privacy violation. Like, if your location is not public to people who are not your friends, people shouldn't be recommending you based on this. And in fact, there are these other articles about how these kinds of recommendation algorithms are super creepy. And to me, this is what's called an information leak. I'll talk a little bit more about what that means. But there are known ways to prevent these kinds of leaks. And in fact, my student reported a very similar bug to Instagram last year and made $1,000. So I had just taught about the leak in class, and then after class he saw that in his email he was able to access things he wasn't supposed to access, and Facebook sent him $1,000. So now that's part of our course advertisement. Yeah, bug bounty. And so you might say, well, maybe the solution is to just not use social media, but these kinds of problems are actually pretty pervasive. So we're currently working with researchers and engineers at the University of Pittsburgh Medical Center. And what they're trying to do is protect medical records. So if you have medical records, you might imagine only you or your doctor or your insurer or other kinds of people are supposed to access that kind of information. But it would be really useful to allow clinicians and people working on treating you to be able to search things like, give me all patients who are under 15 with this very rare diagnosis. And you might imagine that it's both illegal and not a good idea to have results appearing in that people don't actually have access to see. And so right now, they're very worried about enforcing these kinds of policies. This is the same kind of information flow policy, right? It's not just about accessing the medical record directly. It's about accessing it after the software has done some stuff with it. And these are very hard to prevent because of these software problems that I'm talking about. And so from my point of view, the big issue is actually that we're still using very retro programming languages. So if we look at most of the programming languages that people are using today, the constructs are from the 1970s. So security and privacy were not major issues at that time. And so secret data, like I said before, and public data are just all in the program together. So if you look at a program, it's just a bunch of lines of code. No one's saying this is a secret value or this value dependent on a secret value, you gotta be careful. And so as a result, programmers have to navigate something that we call policy spaghetti. So what I highlight here is there's a bunch of code, and then all of the white parts are checks. So there are checks like if the viewer has this role and we're currently in this stage. So this is for a conference management system to manage submissions to a conference. So we're currently at this stage of the conference and they've done this thing already, then they can see this version. And if they have the same role, but we're at this other stage and they haven't done this thing, then they see this version. And so you can imagine it's really easy to get this wrong, because to implement any new policy, to implement any new piece of code, and to fix any bug or do any maintenance on the code, someone has to think about how all of the policies and all of the code fits together. And so you can imagine that even very smart, well-trained, careful programmers, when they're going through and inspecting millions of lines of code to make sure they got this right, can get it wrong. And so our work is about how we can do better. And it's based on a key idea, which is instead of having people live in the bubble, each sensitive value lives in its own bubble. So what we do is secret values now have a special privileged place in the code where they get policies attached to them. So instead of the policies being strewn across the code, the secret values just go in one place each, or the policies go in one place each with the secret values. And they're attached directly to the secret values so that we can rely on the system to enforce these policies if that's what we want to do. So we call this programming model policy agnostic programming. And there are a few main benefits that we see. One is that if the policies are in one place, attached to the sensitive data, then the programmer has an easier time to check that they've done the policies right. The inspectors also have an easier time telling that the policies are what they're supposed to be. So if you're someone who's supposed to come into a company and check that people are doing things right now, the best people can do is audit. So audit is about you keep a bunch of logs, this is who we let see this is who we let see that. Someone looks through and says, yep, that seems right. But if you have policies very explicitly in one place, someone can now go and audit the policies instead of what happened after the fact. And also, keeping the policies in one place allows us to automate the enforcement. Because now if you say, this is my data and this is my policy, you can make a program that goes through and says, OK, this is what it means to automate the policies. So now we can rely on the trusty programming language to enforce the policies instead of each and every individual programmer. And so we developed a language called Jeeves to do this. And it's a research programming language. And what it means to be a research programming language is so what this means is not that we're developing Python or the next Java or the next Scratch or something like that. But what we're doing is we're developing a new way of thinking about programs. And so we can do this by implementing this as a brand new language, as a feature in an existing language, which we've done with Python. So Jeeves is really implemented on top of Python as a way to attach policies to sensitive values in Python. And we can also do this as a way that we retrofit on top of existing programming languages. So one thing we're doing now is we're letting people specify policies attached to the data, and we're working on techniques for rewriting programs automatically to make them enforce policies. And so really what we've done is we've teased out policies from programs, and we say, OK, if you think about programs this way, here are all the ways we can make your software safer. And what's behind this is a lot of math, some logic, and some knowledge of computer programming. So when I was in school, I learned all this random math, and I was like, when am I going to ever use this again? I also really liked learning logic. I thought this is just something people do for fun, but I can't ever do this for a living. But what it turns out is if you like math, logic, and programming, you can make a living out of it by designing new ways of doing programming. So I like to call this turbocharged arts and crafts, because really you're developing new ways of doing things. And what the math and logic gives you is it gives you a way to have provable, mathematically provable formal guarantees on the things you're building. So to me, it's super cool, because it combines my interest in creating things with my interest in knowing that things are what they're supposed to be. And to give you some idea of the other things people in our field work on, well, the most exciting thing, no talk is complete without some logo of NASA. So people in our field also work with NASA. And what we do is, well, not me personally, but what people in my field do, is they work on making mathematical models of programs and proving that space shuttles and things like that won't crash. So they say, this is what the code does in there, this is our model of it, and we can prove that your cars, planes, and spaceships aren't going to crash now. These same kinds of techniques can be used for proving that cryptographic protocols do what we want them to do. So if you have CryptoKitties, or if you do other things that rely on these kinds of complex protocols, you might be wondering, well, how does the software actually get this right? It's possible to mathematically prove that we're doing it right. And then finally, you might be familiar with robots who can automate tedious tasks for us in real life, like vacuuming. But what you might not know is that automated techniques can also be used for automating tedious tasks of programming. So if you're ever learning to program and you say, well, gosh, this part is really boring, I wish someone could automate this for me. Well, there are people in our field who are working on doing that. And it turns out that if you can think of your software as a mathematical system, it also makes it easier to automate parts of programming. And so I'm running out of time, but I just want to make sure that if there's one thing you take away from today, it's that you should learn to code. And I know that everybody else tells you that too, but there are some new reasons that I hope you think about. So first of all, if you learn to code, that's the only way you can join me in making sure that we can have this interconnected future where everything is private. But even if you don't care about that, I hope you realize by now that learning to code is important for understanding software, and understanding software is just one of the big social issues that we're going to have coming up. So even if your interests are less technical or you like other kinds of science, I hope that you learn to code for some amount anyway so that you can participate in these important conversations. Thank you.